Start.
Hello everyone, my name is Jabari Hinton. I'm here with my partner Saad Vinay, and we'll be here discussing the Canon Fenske Viscometer. The objective of this video is to demonstrate and review and understand the function and the procedure of measuring kinematic viscosity of water and milk using the Canon Fenske Viscometer. Now, this viscometer is used to measure the viscosity of Newtonian fluids, and Newtonian fluids, their shear rate and the shear stress are linear in their relationship. So those items would be like water, milk, and other liquids that have low viscosity. So if you can come here and look at the actual instrument, how to use it is you will insert your liquid into the instrument in this first tube. So right now I'm using water. And this is 10 ml. And you will have your water heated to about 40 degrees Celsius. And what you want to do is use your pipette on the second tube of the viscometer, and that causes a suction where the liquid in the bottom of the tube will be transported up into the second part of the viscometer to this first hash line in the bowl. And to determine the viscosity, I'll loosen it just so you can see. To determine the viscosity, after raising the liquid to this first hash mark, the pipette will be released, and the amount of time that it takes for the liquid to get from this first hash line to the second hash line will be used in our calculations for viscometer. And as you can see, after I release, the water is flowing slowly down from this hash mark to the second. And this methodology can be used also for milk, which will be right after I dispose of the water. Now, depending on the size of the viscometer, this one we're using is size 50. That may determine how quickly the liquid passes through the viscometer, and that can affect your measurements. But for today, we'll be using the size 50. So now I'll be inserting the 10 ml of milk, and it should be expected that milk has a higher viscosity than water, so that it should take more time than water to get from this first hash on the viscometer to the second hash. Now the milk has reached the first hash, and I'll release the pipette. And as you can see, it's going slightly slower than the water, and that is evidence of the difference in viscosity between the two liquids, and the calculations for this will be shown in a separate video. Thank you.